That's your homework for today. There's 2 questions there. You all need to get that done. Now, we'll see how long this takes. But hopefully we can rise above and you all are able to go through and go through right now. Sign into your calculators if you haven't already. That's number 1. Number 2, have your note packets out. Open to page 13. Now, we're so lucky and blessed because, and by the way, I know we didn't have class yesterday because of that UN thing, whatever. Your job still, I don't care whether or not you have the class, you're still responsible, even if we miss for whatever reason. If you miss or I miss, we've got to go on. So, if you didn't go through and watch the video, that's fine, but understand that when you come back, it's the expectation that you'll have the video watched and that you'll be caught up to everybody else. We don't have class tomorrow, so you've got to get it done at some point during the break. Period. Is that clear to everybody? Okay. Now, the last thing is this. Because I'm so, we'll say popular, I have such smart students. I have 2 former alumni here. Now, you take a look. There's a beautiful Meredith Ben. And also, we have boys in Nancy Campbell. So they go to 2 pretty decent schools. I mean, they're no SUNY Geneseos, but Notre Dame and Ohio State. Okay? Now, I had the privilege of having these children in class. 2 years back, 2, right? And Meredith 3? Yeah. Meredith sat in the same room that you did. She went through and was blessed enough to have me for 11 Enriched, and then pre-cal, which Meredith, did you earn college credit for pre-cal?
Yeah.
Okay. And then afterwards she went through and took calculus as well. Now, we'll say this nicely. Meredith, was I a crotchety old bag the entire time that I had you for Algebra 2?
Yeah.
Yeah. If you don't mind sharing, what did the first number of your Regent score start with? 9. And did a lot of your friends have Regent scores that started with a 9? No. Okay. And then we had each other for pre-cal. Continued to excel. And then even Mr. Gamble had a nice insight. We had each other just for the 2 years. I probably, let's say this, you probably would have done obviously substantially better on the LSU if I had catch. But, were you successful at pre-cal? Yes or no? Now, this is the one that always I find so funny, because you go off, AP Calc is a big challenge. But here's the thing that he said when he came back, which was the whole reason we do it. In all honesty, I care how you do in pre-calc, but afterwards it's on you. You get as much or it's not as much as you want, and you've got to give calc a try, because it's a whole different mindset. But the thing that's so funny is, and this isn't the first kid that's gone through and said it. I've talked to multiple ones that have. It's not what you do in calc when you're a trader. Because I had multiple kids. There was a student that I had the first year that I did calc. He sent me a text back. He still had to take calc 1 again. He wasn't super successful at it when he was a trader. I mean, you go through, it's a tough concept to get. There's so much rules going on. All these different rules, all these different situations. Am I doing this when I see this? When I'm talking about rate, is it this? Blah, blah, blah. But he said something that was good. It shows that you get it. This is a life success thing. It was so much easier going through and taking it at Notre Dame. Because you have the background coming in from trading. And that's what you all don't understand now. We could sit here and do lollipops and gumdrops and play the flute every day. And we could go through and have cupcake parties and go, oh, it's Christmas time, so we're going to take this whole week off, and we're going to show Home Alone, and then we'll watch Mean Girls, and we'll do a snack sign-up, and we can go through and we'll, please. Do you think people that are going to Harvard are sitting there watching Home Alone and their math classes? Yes or no? Maybe. I can assure you, not if they're going to the actual Harvard that's spelled H-A-V-A-R-D. They're going to H-A-V-A-R-D, which is Harvard, which is right across the street from Harvard. They have almost 30 kids every year. Okay?
Almost the cheats.
Now, so what you have to get is, of course, listen, of course I'm difficult on you, and it's for a reason. Let's say this, because Meredith's the only one that can speak to this. Meredith, did you do better on the reach or your 4 quarters? Which one? There you go. And ironically, when you all come in, we're still operating under the assumption that, oh, the Regents is hard. Did you feel flummoxed when you were taking? Did you feel difficulty or no? No, it should have been nice and easy. That's what it should be for all of you. Are there going to be maybe 1 or 2 that you don't get on there? Sure. But you should leave that exam knowing it pretty closely to what you got. So we need you all to be successful. That's why I'm such a crotchety old bag when I'm in here. Why? Because it would be so easy for me to be popular with you and sit there and go, oh, let's do a mind map of how taking the square root makes us feel. Let's talk about our exponent rules and let's draw a picture so we can figure out something that's going to remind us, oh, yeah, wonderful. We're not doing that. You want to draw pictures? Take our route. You want to do mind maps of fun experiences? That's not what you're here for. We're going to make you leave here disgustingly qualified. I mean, you should leave here and go, this was so easy. This was a walk in the park. I finally know math. Now I can go on and be successful at pre-calc and go on and give myself a chance at AP Stats, AP Calc, whatever you choose. You've got to get it through your head. This is not a walk in the park, period. Number 2, you all just got course recommendations done, right? You're going to see, now we had our individual conversations. I'm going to tell you all this. I encourage every one of you at least to take one of these 2 options. You've got AP Statistics. I recommended you 4, Pre-Calc or Pre-Calc Enriched, whichever one, and I sent a note out the other day. I try to put, in my experience, generally speaking, 87 is sort of where there's a separation. People that score above an 87 tend to be recommended for Pre-Calc Enriched. People that score below 87 tend to be recommended for Pre-Calc Regular. Obviously, there's exceptions to every rule. Sometimes people will get, an 80 in the course and excel and enrich. The other end is sometimes they'll go through and have a 90 in the class and not want to do enrich. It's up to you. I really don't care. But at the end of the day, too, you all have to take inventory of how much work you're willing to go through and put into the class. Because if there is ever any switch, it can blow up your whole schedule, or you might not be available to certain things, etc. Like new visions, I think, is something that happens when you get to be, well, maybe, I don't know if they take June, but there's some things that you get locked out of, depending on what your schedule is initially. You all should take AP Statistics, those of you going into a biomed field. That's going to be something that you'll probably need to take at some point. Almost every biomed major needs it. And the other thing that you need to go through, I advise you all to sign up for at least one comp sci. They're a half-year class. And Ms. Miller works with you tirelessly to make sure that you get through. You can find out if computer programming is for you or not. But we're not going to sit here, though, and the recommendations aren't set in stone. We'll always go through and revisit them. It's not a personal thing if we say, I think you could do X or Y. Some of you are marginal. We'll look at where you're at 30 weeks. But you've got to decide how much work you're willing to put in, how much frustration that you're willing to deal with, and how much if this relates to it. And I'm telling you now, there was nothing funnier than watching the girl sit there and explain to me how she was going to be a photography major. And she's taking AP Chem, Chem, AP Bio, Algebra 2 Enriched, all of these classes that have nothing to do with what she's interested in the least. Nothing. It even bothered me. I remember that there was a girl that I had who said, I think this class is too much. And again, like 7 AP track classes. It wasn't, I think she even took AP Gym. I don't know if they still offer it. There's such a thing. It's AP Gym. Okay? And there's an AP in front of her. She was going to hit it somehow. I had to call Mom, and I'm like, what the hell are we doing? Like, your child is not enjoying being 15. The whole day is homework. They played volleyball, and they did all this stuff. And I'm sitting there going, why? Like, let them play volleyball. Let them do whatever they want. They did volleyball, I think something in the winter, maybe basketball or something. Fine. Enjoy it. But understand, that doesn't mean you have 10 hours at the end of the day to go through and do homework also. So one of those 2 things has got to give. And it's not right, frankly, to you to go through and feel this crushing weight of your classes on you. It's not right. You should be taking at most 1 or 2 APs, period. So if you're on track for some sort of AP, English, and or English, it's too much. Figure out which one you want to do. but you're doing too much to yourself. Now, in order for us, and we said before, we've got these issues that we're going to have where we sort of start running short on time. And this is going to be one of those. The assessment that you picked up when you came in, is for homework. Go over to your note packets now. And by the way, a general rule, just so maybe the little bit of OCD and myself can get managed here. When you take them home, a couple of things to keep in mind, like take a look at this white piece of paper right now, okay? Look at the corners on it. Now there's 4 distinct unbent corners. It's probably a good rule when you hand it back. It sort of looks something like this. Again, there are very, very brave people in the world. I would say that you would have people in the armed services, and policemen and firemen, and then right underneath there is people who do math and chemistry. Because that's the kind of brave I'll never understand. I mean, wow. And if you make a mistake, it's their threat. So let's maybe do it. The third thing is, if you could stay away, there's always maybe 1 or 2 where I'll come back and there'll be some sort of stain on the paper, which is indicative that at some point something was on the paper. I'm not going to try to determine what that was. Sometimes there is wetness that has dried and left some sort of colored residue on it. Again, I'm not making any judgments on it, but if we could do everything possible to make sure that maybe what I'm hoping are coffee stains or other stains maybe don't find their way on the paper. Maybe go to a nice clean area. And when you write, it tends to help if you write some neatness, not as though someone was clubbing you in the back of the head with a tire iron while you're trying to write out your answers to your assessment. So let's make sure we take those things into account. Now, we're going to answer these questions without you going through and using your calculators. You need to get over and stop being so dependent on classes. Take a look at the first question. We're going to graph this, not on the calculator, and we're going to identify the following. Here's my function. It's y is equal to 3 raised to the x. Hands up, please, if you can tell me what the domain on that function. Think about what 3 to the x is going to look like. Think about the ordered pairs that would be on it. You tell me what's a member, or what would our domain be of the exponential y equals 3 raised to the x power. We've got 4 people, really? Awesome. What's the domain? What? Every input gives an output, so the domain would be from negative infinity out to positive infinity. Now, let's take a look, please, at the range. Hands up, please, if you can tell me what are the output values that this function will give. Try plugging in negatives, try plugging in positives. Think about the 0. We've got 2 people. Not our best. 3. Imagine what the outputs are. As enriched students, this should be very easy for you. Well, if 0 get a bracket or parentheses. So, let's go through. It doesn't give out a 0. Now, we'll do one more. Let's ask this first. How do we find the y-intercept? Hands up, please, if you recall that. Really? 4 of us? 5? What do you want to say? No, we're not graphing it. How do we find it algebraically? What? There you go. So we'll set x equal to 0. Hands up, please, if you can tell me what coordinate the y-intercept would have. What's the ordered pair? Jocko, what do you say? 0. Now, this came up as well, and God loves the people at Spry, because I don't know how they can accept that paycheck every week, seeing what comes over, because there's times I sit there and go, what are you doing with you guys? We went through and we had this question from somebody else, and they were looking at me, they go, why is 3 to the 0 equal to 1? And I go, they never showed, this is one of the lowest proofs that you can do, and I'm not going to show you, well, I'll show you easy. Ready? Why does this work out? Let's take this. Let's look at this in terms of, now those are just arbitrary x, they could be anything, right? Who can tell me, please, another way I could rewrite the numerator? Hands up, please, this should be easy. This is not a trick question by any means. What's another way I could rewrite out the numerator? Rebecca? Yeah? No? Just the numerator. Look at the numerator.
X to the power of 1.
Absolutely correct. That's perfect. Now, drastic step, look at the denominator. And Michael, how could you rewrite out the denominator? X. Now, our exponent rules tell us this. When there's like bases, what has to happen between the exponents, Ben? What operation gets done between them? Subtracted, right? So this would be x to what power? 0. All of these so far are equal to each other. Why will this equal 1? You tell me, why is that going to equal 1? All of those have been equal to each other. Every step logically flows from the one before. Why would those equal each other? And this goes back to the whole fact that they've been missing. Talking to you with inappropriate language previously. Yeah. There you go. These are all equal to each other. That's why we go back to, and they say, oh, it's not significant. Oh, we can say cancel. Baloney. That's garbage, and it's lazy language from people who should know better. So looking at what we've got now, these do not cancel each other out. What's x over x times x over... What is x over x equal to? 1. That's a reduction, not a cancellation. If a credit card gets canceled, how many credit cards do you have? 0. If you've got 7 over 7, that's a reduction, not a cancellation. Now, we're going to give this out. You don't need a calculator. We're going to list out 7 x's. We got -3, -2, -1, 0, 1, 2, and 3. Who can give me what my outputs are going to be? Are you leaving those? We'll see you later. Don't be strangers. You're throwing it away? I'm so crushed. By the way, did you have assessments every day? For 3 straight years and for 2? Did you manage? Okay, see? Isn't that nice? See? He's not even the best on his team. He's only number 3 for Division 1. Now, who can tell me what's an ordered pair that's going to be on this graph? What's an ordered pair that's going to be on this graph? People, what do you say? Pick any x that you want and tell me what the y would be. Perfect. 0, 1 is on there, so now I go and put a dot. And by the way, yes, you make your graphs accurate. Mine is always off. I'll tell you now, because somewhere's always a couple pixels off, but in a graph this small, it shows up. Who can tell me another ordered pair that's on this graph? Teresa, what do you want to say? So 1, 3, that's a point. 1, 3, boom. Jake, what do you say here? 2, 9. What? Yep. Perfect. See, we're good. You're better than plastic, guys. I'm telling you. This, and you've got people that will sit there and go, the decimal is 0.3 repeating? No. It's a fraction. Don't be afraid of it. Embrace doing that. What do you want to say? Perfect. What else? Who's got? Is there any more we're missing? Yeah. That's terrific. You're doing great. So now we're going to plot all of this out. Watch what happens as I go, and this should be kind of obvious. As I go out to the left-hand side, guys, where is this graph going to? 0. Did we talk about asymptotes before, where it gets infinitely closer, but it's not going to touch? That's my asymptote here. This graph, by the way, is pretty decent, although it rises for a little bit towards the end there, and it shouldn't. But I'm going to tell you this. That's as accurate as you all can give more accurate graphs than I can, because you're more precise with your pens and pencils. I'm going to tell you this nicely. Stop giving me nubby, stumpy, incomplete graphs. And what's the one thing that back in 5th and 6th grade we should have been losing points for that you all are still forgetting on your graphs? Because I'm going to start, if I haven't already, the points start coming off, especially if you're towards the end of the test, and I've seen about 5 of them start getting irritated. He's absolutely right. And you all know the mistakes you're going to make. You leave those arrows there. Come on. You're better than that. What? Now, I like it if you do on the Reg and on exams. Yes. On tests for me. Yes. On the Reach, I don't know if it's a deduction or not, but if there's two graphs on there, I would always label guaranteed, no matter what the situation. You can see how long that took for us to do. Now, we're going to have to sort of hustle through. Take a look at this next one here. What shift is getting done on the parent graph if I'm graphing out? You don't need to graph this on a calculator. You can use the calculator to confirm it. But don't, now, look at what's there. What transformation is getting done in A on the parent graph to get this graph? We got one person who can tell me. We've done this already. This is not a new topic. We got 1, 2, 3, 4 of us. Oh, come on, guys. Come on. What transformation do you think we would do on this? Exactly what do you want to say?
You should just break it.
He's absolutely correct. This graph, we have to shift over to the right 3 units. By the way, did that proof to you all make sense? Yes or no? Did it? It should. Were you shown that before or no? See, that's my problem is when we go through and we do stuff with you, it's not fair to you to blindly say just memorize this and become like a little dog. You're smarter than dogs. You've got to go through, and yes, if you need to, can you memorize the rule? Sure. But there's no mystery as to why things like that happen. And these things should be explained to you as to where they come from. It's not from some edict from the central math office of the world. You go through and we say, this is why it is what it is. And everyone's capable of knowing it. How long did that take to explain it to you? How long? 2 minutes? And if it makes sense now, maybe that would be a great test on, or a bonus on a test. Show me why 5 to the 0 power, what was it on there? 3 to the 0 something? Yeah. Why 3 to the 0 would be equal to 1? Prove it to me. Doesn't, by the way, that's somewhat of a proof, because what you're saying is, does it matter what the value of the x or the base is? No, it works every single time. No matter what the base is, it works every time. What about for B? Hands up, please, if you can tell me for B. What do we got? Yeah? You betcha. We'll do a whole class of just proofs one day. Not geometry, actual good proofs. Yeah? What do you mean? Sure. You'd say let x equal any real number. And then you say, all right, well, I'm going to multiply, let's say, 4 or 5 together, right? As long as the same number of x's show up in the numerator and denominator, so that would be x to the n power for any number. It could be 4, it could be 5,000, doesn't matter. So x to the n power over x to the n power is the same as x to the n minus n power, which is x to the 0, because n minus n would be 0, and then x to the 0 has to equal, there you go, you just made a proof. And they act like you can't handle that. Could you have handled that in 8th grade? Are your brains developed enough to? No, I think so. I think so. Now, when we go through and look at this, take a look at the next one. This is always interesting because you can go to the calculator to check, and we're going to show you there's a big difference on what this shows. This is the sorry, not this one, next one up. Looking at this, this is going to cause one transformation or 2 possibilities. We'll go through in the calculator and confirm on it. Hands up, please, if you can tell me what this is going to go through and show to you. Yeah?
A reflection of the y-axis.
Let's double check. Now, those of you who have a strong math capacity, we're going to say reflect. And thank God you use right, because what do a lot of lazy layers, what are they going to say? Yeah, flip. We're going to use actual words. We're going to reflection over the, and you said y or x-axis. I don't want to get it wrong. Okay, so if this then is the original, now watch what happens to my x. So I'm going to make a table of values to double check to see if he's right. You can go in your calculator if you want to in a minute. In a minute. No. Plug in some x's. You've got, let's say, -2, 0, and +2. Looking at what's there, we would go through, and Felix, if that's the function, when you plug in a -2 into that function, what would you go through and get? Nope. He's not correct. What do you get when you plug a -2 in for the input in that function? What? Positive 9, because it's the negative of negative 2. Now the next one up, when I plug in a 0, Caleb, what would you go through and get out?
1.
What about when I plug in a 2? Spencer? Nope. 1, 9. So that graph is then going to look somewhat like that. Could you go in the calculator to confirm that? And the answer is yes. But, especially as enriched students, even if you don't see it, make a table of values. The math is not complicated. Don't be so dependent on the plastic. Now, as we go over for this next one here, when we do these ones out, the first thing up that you should see is the shift is getting done outside of the argument, outside of your input. This right here, when we do this out, this is going to be shifted down 3 because it's outside of your argument. Now, that's going to change what our asymptote is. Hands up, please, if you can tell me what the new equation of my horizontal asymptote would be. We stated before that it was a line y equals 0. What would the new horizontal asymptote be? It's going to get infinitely close to but never touch. Perfect. Y equals negative 3. Now let's take a look at our next function. Which when we do this out, here's the parent graph. Now, what transformation is done in E? Angel, what would you say? You're absolutely correct. We're going to shift the graph up 4. That's going to modify what our horizontal asymptote is. And Aaron, what would the new horizontal asymptote be? Close. Give it as an equation. Absolutely right. Don't forget that piece, but the numbers were correct. Questions on that? This is the part where all of you are going to screw this up, and this is the part that makes such a great enriched question, especially without the calculator initially. Let's make out a table of values for this, because you all are going to screw this up probably pretty bad initially. I'm going to start off and give me 3 points. Let's do 2, 0, and 2. Sorry, negative 2, 0, and 2. Now, looking at what's there, I want to stop us and say this. I'm going to start off with a negative 2. When I plug in a negative 2, hands up please if you can tell me what the output is going to be. When I plug in a negative 2 into that as it's written, what would my output be? We've got 4 people, 5. Take a look, it's okay to get it wrong. It's okay. What? Now, it's not going to be a 3. It's going to be the negative of 3 to the negative second power, which means 3 to the negative second is 1/9, then negate that. So this would be negative 1/9. When I plug in a 0, what would I go through and get? Deanna? Careful. What's 3 to the 0 power? Then negate it, because there's a negative in front. It would be negative 1. And now let's go through and fill in a 2. Who can tell me what we would get if we fill in a 2? Perfect. Now let's think about what that graph would look like. You get something, well, that was not, something that looks sort of like that. What type of reflection or what transformation does that cause? Michael?
Reflection of the x-axis.
There you go. Now, looking at, yes. Here we go. Let's have a great conversation because you're going to see something that deals with a bigger picture issue. What we're going to state now is this. Let's consider both cases. Is it the base of 3 to the x and then negate that, or is it negative 3 raised to the x power? Now, and in the second scenario, it's a negative 3 to a power. Now, I want you to see one of those is illogical to graph, and we'll go through and state why as we discuss this out now. If I start off and I take the negative of 3 raised to the x power, that would give us all of the values that we just got now. 1/9, then negate it. evaluate out 3 to the x, and then negate whatever value we got. So it's changing just the y. The x's are the same. That's what caused it to get reflected over the x-axis. Now, the cool thing happens when you start imagining this. Toy around right now with making a table of values in your head. If your base is -3, and you're raising that to a power. Think about that for a minute, and I want you to raise your hand when you can tell me something that you noticed about if you take -3 as the base and raise it to a couple different powers. Watch what's going to happen as you do it. We got 1, 2, 3 of us. Just one thing, Stephen, what do you notice?
Keeps going for positive. Right?
Yeah, tell me a number that you want. What's an input you want to try?
Okay, 1, then
So watch what happens. If I plug in a 1, if it's -3 to the first power, what's -3 to the first? -3. What's -3 now to the second power? 9. What's -3 to the third? Now, go into your calculators, and hopefully we can do this rather quickly. Go into your calculators right now, and what I'm going to ask you to do is this. If you haven't signed in yet, go through and do so. But all of you should be signed in at this point. Said it twice. Now, go into your graph, please, and what you're going to do, go into your graph, make a new graph, and we're going to graph out 2 equations. So the first one we're going to do is -3 raised to the x power. Go through and do this. Whose is this? Stephen, get with us. Go to type in -3 raised to the x power. Now, and hit enter. That's your first graph. And that looks like what we just said was going to happen. Now, the second one is kind of cool, but you have to wait for it because this actually causes a syntax computation overflow in some cases. It used to in the old calculators. Go into your calculator, please, now. We're going to add a second graph. And in parentheses, I want you to make the base -3. So go in right now, please, and put another graph on there. No, on the same set of x. Okay. Graph, a function, sure. And we're going to go through and put in parentheses -3. Now raise that to the x. They are profoundly different expressions. And watch what's going to happen. Now as you do it out, no, just raise to the x. Okay. So when we do this out, you're going to get this graph. Now it's going to look like not a lot's going on. It's riding along. And then eventually, is this even robotic? Did you graph that?
Yeah,
It'll take.
Go over to 4. Or sorry, just go in, what is it, can you tab or something?
Yeah.
Just escape from there, Stephen, and hit tab, arrow back up. Arrow back up. So, press enter on that. Hit enter again. Press enter again. As you do this out, you're going to get here. These start showing what's going on. Those of you that did it will see this happening. And what ends up happening was that oscillating behavior that we were talking about before, which is the graph is jumping between positive and negative values constantly. And it's difficult. The graph is trying to connect those points because it's saying, here it's doing this, here it's doing this. So every time, keep in mind, every time you raise it to different powers, it's going to be evaluated differently. So the 1/2 is going to give you a different answer than the 1/3, which is going to give you a different answer than the 1/4. So every fractional value is pinging up and down and up and down. And what's ended up happening, the graph is compulsively trying to connect all of these points. But what it's saying is the point 1/2 goes up here, point 1/3 is down here, 1/4, 1/5, or something like that. As you work your way across those different fractional exponents, it's bouncing between them. And it's perpetually bouncing between them. Because there's actually a whole bunch of number theory in here, because the number theory says in between any 2 even numbers, we'll say this, between any 2 fractions, there's another fraction. So if I have 1/2 and 1/3, somewhere in between them would be 1 over whatever 3.5 is. And then somewhere between 1/3 and 1 over 3.5 would be the equivalent of 1 over 3.25. And so on. So there's an infinite number of numbers that you can go through and encounter. So even between 0 and 1, there's an uncountable number of possibilities. In between 0 and 1, there's an uncountable number of possibilities. And the calculator right now is trying to rationalize that and make sense. But you have to understand that the calculator, this graph, I mean, you can go and zoom in. Actually, do this. You'll see something kind of cool maybe if we do this. Go into, and we don't do zooms very often, go into menu, please. And watch this. Go into 4 for window. And we're going to do a zoom box, which is 2. So pick anywhere you want to on here. You're going to have to create a rectangle. So maybe like go right in here, like somewhere right up in here, whomever this is. And your box right now is going to be really, really small. So hit enter on that. That will make our first corner. And then go down and maybe, yeah, sure. However you want to go over to this side a little bit more. Make a small square, hit enter on that. It's a really, really small square. What does this graph look like when I start zooming in? Now, I don't know if it's going to come up or if it's going to take a while, but this should be violently fluctuating between the values over time. And I don't know if we've done, well, we encountered enough there to make it happen. I don't know, does it come up?
Yeah.
Okay, wait a minute. It should actually start to come up and look like a barcode. It did? Someone got it. Let's see. But when we zoom in, something's off about this one. When you zoom in, now it does? Okay. So here, this is what that graph's behavior is. So even zooming in, okay? Even zooming in, it's still a disaster. That's something, though, that you all are very, very capable of understanding as to why this comes out the way that it does. Now, let's go back and we'll try to finish this up quickly. Taking a look at what's there, take a look, please, at G. When we go through a G, what transformation is getting done on G? You know that. Remember, our base function is 3 to the x. What transformation is getting done to graph out G? You tell me. Use your words. What do we say that this is going to end up being? We got 4 people, 5, 6? Yep. Because the A value is greater than 1, this would be a vertical stretch. Hands up, please, if you can tell me what we would go through and do and say for H. What would we say for H?
Vertical stretch.
Because the A value is between 0 and 1. The absolute value of it, technically. Looking at the next one, there's 2 transformations. You tell me, what are the 2 transformations that we're going to get? Yeah. Reflection over what? And? No. It's still getting bigger, but instead of it getting bigger going up, it's getting bigger going down, if that makes sense to you. Okay? The negative just causes the reflection. The 1.5 causes the stretch or shrink. Okay? Next one up, we've got to label what all of these are going to end up being. We'll tell you this to start this off. The A value is your vertical stretch or shrink. Take a look at the B value. Hands up, please, if you can tell me what that B represents. Yep. Nope.
Base.
The base. That's whatever our base is. The A is the multiplier in front. What does the H control? Who remembers that? We've done this already, and you discussed it previously. Look where the H is. What's that going to help us get? We got 4 people. Stephen?
H is the horizontal shift.
And how about the K value? Jordan, what would you say the K value controls?
Y-intercept?
Nope. That means it impacts y-intercept, but it's a broader perspective. Go ahead. That?
Vertical shift.
Yeah. Now, take a look, please, at 1. You tell me what the answer to 1 is going to be. Read what's there. What's the answer to 1 going to be? We got no takers. It should be pretty automatic. Thank you, Steve. Angela, do you know what this would come out to be?
Y equals 3 times y equals 4 to the x minus 5 and then minus 7.
She's absolutely right. Questions on that? You're all stars. Let's go. Take a look now, please. We've got two more that we're going to look at. Answer out number 3 right now, please. Okay, tell me, please. When we get it, there's 2 transformations done in 3. You tell me when you can get one of those transformations. What's one? Can you give me the other one?
Horizontal shift, left 6.
Now, these next two are, for some reason, and this is why I laugh when they tell us that you can't do well on the read, because I'm telling you right now, the questions that you're working on this read are going to be so easy if they keep loving these 2 formulas as much as they have been. What you need to see is, and these are very low-level concepts, if there's growth, you take the initial amount, which is A, times 1 plus whatever your growth rate is, times t, or sorry, raised to the t power. Raised to the t power, not times t. What that means is you're computing growth over and over again. Because the thing that's interesting is growth can happen on top of growth. Now, if there's decay, it's 1 minus. But decay happens. Now, here's another thing, too. That baffles me. That for some reason they act as though this is tough for you to understand. I really don't think it is. Let's ask this right now. They always do these questions, particularly when you're going through and doing percents. And it's frustrating to me because they're treating you as though you're not capable of thinking, when you really, really are sharp people. Looking at this, and it goes back to the significance of whatever this number is here and how that plays into the exponentiation. Think about this. If you go into a store and you buy headphones for $100, you walk out of the store and pay $100. No. What do you still have to pay? Hands up, please, and tell me what they don't. And this is always the question they ask. Well, tax. I think tax in Monroe County is 8%. Now, to figure out what amount you're going to have to pay at the register, hands up, please, if you can tell me what you would multiply your $100 by to figure out how much your final price is going to be. You know?
1.08.
1.08. Multiplying by 1 preserves the original amount. Adding 8% to it gives you the original amount plus. Didn't they, when they asked these questions, at least when I remember, they would always go through and they'd say, well, find out how much the tax is, and then add the tax in the original. Did they do that?
They said that was optional. They also showed us this.
Yeah. The number of you that saw that, though, was the primary, especially low-level kids and mid-level kids. You're not doing anything. Nobody cares how much the tax is. They want to know how much the final amount is. No one's sitting there going like, well, Edith, we paid $86 for this, and then an additional $5.48 for this. No one cares. It's the same thing as if you go into Kohl's and there's a sale, which they have all the time. You go into Kohl's and let's say you find that same headphones. And now to figure out how much you're going to pay, you've got a 20% off coupon. So what are you going to multiply the amount that's there to figure out how much you're going to pay? What would you multiply? You've got a 20% off coupon. What are you multiplying the original $100 amount by in order to figure it out? Caleb? 28. Because you're not paying 20%, you are paying 80%. You take 100 minus the 20. And then, by the way, Caleb, what would you do to that new amount to figure out how much your total register sale would be? Multiply by 1.08. They do this in this precocious way where they're like, figure out what 20% of it is, subtract the 20% from the total, go back over here, add tax, you've lost interest and you're not thinking. Like, that's what I don't grasp. So if you multiply something by 0.93, is that growth or decay? Hands up, please, if you can answer that. If I multiply an amount by 0.93, is that growth or decay? What? Decay. What percentage of decay is it if I multiply by 0.93? 7%. Well, that's not tough. but they treat it like it is. And it gets frustrating for mine because you can do these things in a really small amount of steps. What? Now, no. Well, it all depends, because actually this is interesting. I worked at Wegmans when I was growing up in the pharmacy for probably 15 years. And it was always very interesting because the tax, especially in New York, is very awkward. So, food, you never pay tax on just food. But if you go into Wegmans, if it's deemed like a core food, you don't pay tax on it. If it's a sugar-based food like candy and soda, you do have to pay tax. Now, this is what's interesting, because sometimes I don't know if you realize or not, I drink a lot of Diet Coke. And Diet Coke is taxed. In spite of the fact it doesn't, actually, no, Diet Coke is taxed because it's like an alternative but non-healthy product. So, when I go through and do that, if the sale, it depends on where the sale comes from. And the only reason I know this is because I was reading it up wrong and they tried to fire me over it. I was giving, you charge tax on the original amount if the manufacturer is offering the sale. So if Coca-Cola is giving the item out for, you know what I mean, now Coke products go on sale or Pepsi or something like that, and sometimes they like your parents, whose parents like stock up when there's a sale on Coke or Pepsi or so. In any case, if I were to buy like a 12-pack and the sale is coming from Wegmans, then you pay tax on a small amount. If it is coming from Coke, you pay on the big.
Do you have to know that?
Thank you. That's what I'm saying. Like I said, I can go to Cornell for finance here. Okay. At the time, I was going to Geneseo for math, but still, it's not Cornell. Now, someone would have to tell you. But in any case, like if you go to Kohl's, something like that, you take the percentage, because those sales originate at Kohl's. So it's Kohl's sale, not from the manufacturer. So you only pay it on the lower price, okay? But there's sometimes, it's a New York thing, where they wouldn't. Now, looking at what's there, take a look at question number 1. Because the stuff we're doing now, these are the actual questions you need to be ready to answer on the read. Take a look there, read number 1, and tell me whether that's an example of exponential growth or decay. You tell me whether that's an example of exponential growth or decay. You've got 4 or 5 of you, 6, get real. Oh, Olivia, what do you say? It's going to be growth. So here's my model. By the way, a model means it's got 2 variables left in it. Here's what I'm starting with. Who can tell me what I can fill in to complete this model? And this, again, is enriched students. This should be quick for you. You should make sense. This is a real-world thing. They go up with time. Got 3 of us. What's a variable replacement that I can make? Lily, what do you want to say?
Do 1.4 for A.
Close. Yeah. And she condensed it, and that's terrific. I want you to get to that point. If you need to write it out as 1 plus or 1 minus, that's fine too. What else can we fill in? We know with the t is going to be time forever.
Our R value is, A value is 968.
968 to start. This is the model. You use that to get all future values. Now, what would we do to answer out B? Hands up, please, if you can tell me what you would do to answer out B. So you said what? What am I putting in for T? Close. Who can tell me, please, why this is wrong? Which would be how many years? Go into your calculator now, and some of you are going to notice. Does this give you how far to round? Does it tell you how far to round?
No.
No. It's implied you're going to make a connection here. So you're going to go in. You could either put the model in and then do a bar and then do t equals 15, or you can do a direct sub in. It doesn't matter which one you do, but you need to get it done. And Logan, let us know what you give as your final, please, when you get it.
$1,743.31.
Now, why did you stop at 2 places?
Because money doesn't go past that.
Perfect. Take a look now.
According to gas station, it does.
Now, where's the other one? Let's do this out to make sure we've got this. And this one, I'm not trying to be morbid when you do it. But this is always one that actually, this is a real life, some of you might have had experience, and I'm not trying to make it painful when you do. But I was actually thinking about this raise your hand if you take chemistry in here. Who amongst us? Okay. So that's by and large most of you. And when you're doing chemistry, this is something that you go through and deal with. And it's actually impacting sort of our family. My sister has thyroid cancer. She had the tumor removed, but she has to go in for radiation. And one of the things about the radiation is she can't be around people for 2 weeks after the radiation treatment. Now, does anyone in your family or know somebody that's happened to? Yes? No? Yeah. When it happens, it's because the person has been exposed to a large amount of radiation. The radiation is there and targeted to kill, if it's for an oncology process. It's to kill any cancer that's there. The person actually becomes sort of dangerous to other people because they're still carrying around radiation in them. And actually, if you did that, did you look at Marie Curie at all? Does anybody know who she is?
Yeah.
She was one of the pioneers of it. It actually had nothing to do. Her husband was a big dumb idiot. And she went through and did all of this tremendous work with radiation, and she ended up dying from cancer. But her notebooks right now, the part of the story, is that her notebooks from working with it, even now, full of her original notes are too radioactive to be touched, because she was working and holding large amounts of radioactive stuff all the time. But in any case, this is what a rough estimate of what an oncologist would use in order to figure out how much, what your dosing is, and then how long you need to be isolated for. Because you need to figure out how long it's going to take to get out of your system. Now, to start this off, this is going to be an exponential decay problem, and it's going to be the end amount is equal to the initial amount times half of the time over the half-life. And I'll tell you this, if I'm you, I memorize this formula because it's not given to you on your unit exam, and it's definitely, well, it could not be given to you on the reach. I'm not sure, but it's definitely not given on your unit exam. Looking at what we've got, we're going to make some replacements in. So we don't know how much is left after 16 days, but we can figure that out. Hands up, please, if you can tell me what replacements we would make in order to finish, in order to get this final amount. We got one person. What's one of them? What's one replacement? Michael?
Initial amount is 12 carries.
There you go. Who can give me another one that we go through and fill in? Giacomo?
H is 8.
H is going to be 8. And can you give me the numerator, Giacomo? 16. Now, this is an expression. Before you blindly go to the calculator, look at what's there. So as we do this, this is A is equal to 12 times 1/2 squared. Hands up, please, when you tell me how much 1/2 squared is going to be. You can go to the calculator on a test if you're panicking. What is this going to? Yeah. Yeah, if I square it, I get 1/4. So now I've got the end amount is equal to 12 times 1/4. What's 1/4 of 12? Or to put it in perspective that you heard, the pizza has 12 slices and someone eats 1/4 of them. How much do you have left? We've got 4 or 5 of us. Oh, 3. Sam, do you know how much? Nope. Careful. 3. Yeah. Now, you could use the calculator to confirm that. We'll do 2 more quickly because this is one that gets interesting too. These last 2 are actual read questions. Looking at what's there, you've got to figure out which one's growth or decay. You need to look at the base values. If the base is greater than 1, it's going to be growth. So the first 2 are growth. No matter if the power is positive, we don't need to do any manipulations. Now, this one here I need to rewrite. Who can tell me the correct way to rewrite out number 3? Hands up, please, if you can tell me the correct way. What?
Same thing. Let's do the same thing for tomorrow. Tomorrow is also ugly
2
sweater
to
day.
the positive
Wear your
t.
best
This
ugly sweater.
is growth.
Also, tomorrow is an emergency drill release.
What about 4? How would I rewrite out 4? Because it's not correct as it's currently
It will
written.
be at
Who
2:10.
can, really?
The only
Really?
scheduled
What?
impact will be that the 7th period will end at 2:10.
Y is
That's it
equal
for
to
today.
1/5
Good night, and see you
t.
tomorrow.
This is your decay. And I'm telling you now, I'll tell you this. This last question was on the reach. I want you to go through and do it as well tonight. Get this done. If you want to see it done, by the way, so you get it right, scrub to the last of the section 1 video. The other thing, do we see each other tomorrow? The last thing, did I go over your do good projects? You have another one over the break. You've got, listen, take the goodness you did before, and guess what you've got to do to it? Square it. It says it right on it. Do even more good this time. That's your homework for over the break. I'll collect both assessment 27 and assessment 28 when you come back. And I may send out to you a Math Excel assignment. That's another thing, sorry. We'll have a Math Excel assignment as well.
Lesson 7.
You'll have a Math Excel waiting for you.
I should let it stay there over New Year's.
You did a great job today. Thank you.